kids, Miss McQuaid. So we're going to talk about atomic radius, and here is our friend, the atomic radius snowman. So we looked at this already in class, but we're going to take another bite at the apple and take another look at it. So as you go down a group, we learned that the radius increases, and we learned that this happens because the number of orbitals in the atom increases as you go from the top to the bottom of the periodic table. So, if this represents group 1, I could choose any group. I'm choosing group 1 because it follows the trend beautifully. So, if I take a look at group number 1, and I look at the elements in group 1, I can see that I have hydrogen. And this first circle here represents just the orbitals. So I'm going to go ahead and put my nuclei in all of my atoms. Those little plus signs are the nuclei. So here I have an atom of hydrogen. Now you should also have out your periodic table of the elements. So follow along on your periodic table with me. Underneath hydrogen we see lithium. So this represents lithium. Underneath lithium, we see sodium. So this atom here represents sodium. And underneath sodium, we see potassium. Now, when we take a look at the electron configurations, we can see similarity with all of the elements in group 1. They all have one valence electron. But what's different is their number of orbitals. So, hydrogen has 1 as its atomic number, and its electron configuration is just 1, has only one orbital. Lithium has an atomic number of 3, and its electron configuration is 2, 1. Therefore, it has 2 orbitals. So, hydrogen has only 1 orbital, lithium has 2 orbitals. Sodium has an atomic number of 11. Sodium's electron configuration is 2, 8, 1. That means that it has 2 electrons in the first orbital, 8 electrons in the second orbital, and 1 electron in the third orbital. So, it has 3 orbitals altogether. Potassium has an atomic number of 19. Its electron configuration is 2, 8, 8, 1. It has 2 electrons in the first orbital, 8 electrons in the second orbital, 8 electrons in the third orbital, and 1 electron in the fourth orbital. So it has 4 orbitals. So as you go down a group, the atoms add an orbital. The radius of any circle is from the center to the edge. So since we know that the radius of a circle is from the center to the edge, we can apply that same idea to atoms. Now, in an atom, the center is called the nucleus, and the edge, the outermost part of the atom, has those electrons in the outermost orbital, and we call those the valence electrons. So instead of saying from the center to the edge, we say from the nucleus to the valence electrons. So as you go from top to bottom down a group, the radius will increase. As the atomic number increases, there are more orbitals. And that's why we say that this looks like a snowman, the atomic radius snowman. Now, what happens as you go left to right across a period? So, elements in the same group, we learn, have the same number of valence electrons. Elements in the same period, we learn, have the same number of orbitals. So let's examine all of the elements in period 4 as we go left to right. So I'm going to go ahead and copy. And I'm just going to go ahead and paste my orbitals right there. I'm going to go ahead and group them so I can move them as one and be able to clone them. So, now that I know that I have my representation there, now which element was that again? That's right, potassium. All right. right, so we know that this is representing potassium. We are then going to represent each element as we go left to right across our period. So after potassium, number 19, the next element, number 20, is calcium. And the next element, number 21, Sc, scantium. And titanium is number 22. So, let's examine their electron configuration. Potassium has an electron configuration of 2, 8, 8, 1. It has 4 orbitals. Calcium's electron configuration is 2, 8, 8, 2. It also has 4 orbitals. But calcium is something different. Instead of having 19 protons in its nucleus pulling on those electrons, holding them in, positively charged nucleus, negatively charged electrons pulling them in, there are 20 protons pulling. So, more protons means a greater force of attraction. Therefore, the radius of calcium is just a little bit smaller than the radius of potassium because it has 4 orbitals but more protons in its nucleus. Scantium has 21 protons in its nucleus. Therefore, it will also have 1, 2, 3, 4 orbitals, but its orbitals will be closer together. So, we can look at it. I'll move myself over here, like this. Titanium also has 4 orbitals, but it has more protons in its nucleus. So it's going to pull on those 4 orbitals closer. So as you go from left to right across the periodic table, and you have potassium, which has 4 orbitals, but 19 protons pulling on those electrons. Calcium has 20 protons pulling on the electrons. So the radius will be smaller. Scantium has 21 protons, so it will be smaller. Titanium has 22. So the more protons, the smaller the atom is because there's a greater pull from the protons in the nucleus on the electrons. Same number of orbitals, but those orbitals get closer and closer toward the nucleus, pulling on them. So, we can think of this trick. I'm going to move myself up here. So here's our atomic radius. As you go down a group, the radius is going to increase. But as you go left to right, it's like the snowman falls down. He's just too top heavy. And that radius, as you go from left to right across a period, because there's more protons in the nucleus pulling on those electrons in the valence orbital, as you go from left to right, the radius decreases. So that's the most important trend in the periodic table. As you go down a group, the radius increases because there are more orbitals. As you go across a period, the radius decreases because those orbitals are the same number of orbitals within the period, but more protons have more pull, and the orbitals get closer and closer. So, The largest element that exists is in the bottom left corner. That element is francium. The smallest element is in the top right corner, and that's helium. Helium is the smallest, francium is the largest. That's the trick.